All right, video number 3. Found something to improve it. The pen was way too big. So let's go to this next question. We have an evaluate. We have a difference here. So we're going to use a difference identity. So we have our angle A is 45 and our angle B is 60 degrees. So going and looking on our formula sheet then, you're going to see that it's actually cosine A. So in this case, our A value, our A angle, sorry, is 45 degrees times our cosine B value. So in this case, our B value is 60 degrees. And we're going to actually subtract those. So the minus sine of our A value, which is 45 degrees, times our sine of our B value. Now when we're evaluating this, we're just looking from our unit circle. So cos 45 is square root of 2 over 2. And we're multiplying that. Cos 60 degrees is 1 over 2. And then we're going to sine 45 degrees is 1 over 2. And sine 60 degrees is square root of 3 over 2. So at this point, we're just going to multiply. So square root of 2 times 1 is square root of 2. 2 times 2 is 4. And then 1 times square root of 3 is square root of 3. 2 times 2 is 4. Now again, we're kind of lucky. We already have a common denominator. So I got to figure out how to make this thing scroll better. But square root of 2 minus square root of 3 all over 4. So that'll be a different video improvement, how to scroll down. All right, moving to the next question then. We have evaluate. So this one's a little different. We haven't done anything with tan, but these identities are on the formula sheet. So again, on the formula sheet, it's going to look at the first value is our A, second one is our B angle. So on we have an addition here. So this, again, coming from the formula sheet, is going to say that it's tan angle A, which is pi over 4, plus tan angle B, which is pi over 3 in this case. Now, all of this is over 1 plus, I take that back, 1 minus tan angle A times tan angle B. In this case, angle B is pi over 3. Now, it does say to evaluate. So this is something we talked about before. We know that tan is actually equal to, so in tan theta is actually sine theta over cosine theta. So if you go back to your unit circle, look where pi over 4 and actually do the division. Now, I don't have enough space here to do all of those divisions. Hopefully, you remember from further back what that's equal to. So I know that tan pi over 4 is actually equal to 1. Again, using those divisions, so if you look at pi over 3 and divide sine by cosine, you will hopefully find that it's the square root of 3. If you're having trouble with that, just leave a message and we can put a video to remind you of how to do that. Then looking at the denominator, so tan pi over 4, we already said that was 1. And then tan pi over 3 is going to also be square root of 3 again. Now we do need to simplify this as much as possible. So 1 times square root of 3 is square root of 3. Now, the problem here, though, is we have a radical in the denominator, so we need to rationalize. So I'm going to have to multiply by 1. That's way too big. There we go. 1 plus square root of 3. And what I do to the denominator, I do to the numerator. So if you've forgotten, we're multiplying what's called the conjugate. So the biggest difference between the denominator and our conjugate is the subtraction becomes an addition. I'm really regretting not figuring out how to make this board bigger, but we're going to actually simplify this. So 1 times 1, so using FOIL is 1. This is a perfect square, so I do know that that middle term is going to be 2 times the square root of 3, so it's just double. And then square root of 3 times square root of 3 is 3. Now in the denominator, this is a difference of squares, so it's going to end up being 1 times 1, and then square root of 3 times square root of 3. So I'm going to get negative 3. Now unfortunately, again, space is at a premium here, so I'm going to go and erase this. 1 minus 3 is actually negative 2. Where that negative goes isn't a big deal. I'm going to actually put that negative sign in front of everything, sort of. We'll put a different color. So some keys here, make sure you're rationalizing. So we have that conjugate. That's from grade 11. And we have now evaluated. We're going to leave it an exact value. Yes, I can put it on a calculator, but then all of this was kind of for waste. Oh, we're going to skip that one. I've decided just now. So it says determine the exact value. So cos 165 degrees, if you go and look, it's not on the unit circle. So that should be tell you right away, hey, I have to use an identity. So I have to think about two angles that add up to 165 degrees that I know are on the unit circle. So for me, I know that 45 degrees plus 120 degrees is equal to 165, and both 45 degrees and 120 are both on the unit circle. Once I have that, I can actually use my identity now to figure this out, or at least the exact value of it, which is our goal. So going to the formula sheet then, I'm going to find that it's cos times angle A, and angle A in this case is 45 degrees, times cos angle B, which is 120 degrees, minus sine A, so our A angle, which is 45 degrees, times sine 120 degrees. So now we're getting somewhere. We can actually start evaluating this. So again, from the unit circle, 45 degrees, cosine is equal to square root of 2 over 2. Oh, sorry, it's not working. No. This video may just abruptly end. Oh, maybe not. Then cos 120 degrees is negative 1/2. And then a subtraction. Sine 45 degrees is square root 2 over 2. And all of this, again, is coming from the unit circle. And then sine 120 degrees is square root 3 over 2. Now, we're not done. We have to determine the exact value. So we're going to do the multiplication. Hopefully this works at the bottom of the board. Square root of 2 times negative 1 is going to be negative square root of 2. It's not going to work. So I'm going to have to write this over here. So you get negative square root of 2 over 4. And then, now we do have a subtraction between these. Square root of 2 times square root of 3 is square root of 6. And 2 times 2 is 4. So once again, we have a common denominator. So we should actually make this into one term. So we get negative square root of 2 minus square root of 6 all over 4. Okay, moving on to our very last question before the diploma question. So it says, well, it doesn't say it, I guess. I want to determine the exact value of this angle. So tan 5 pi over 12. So if we go into our formula sheet, or sorry, unit circle, you'll find again, we don't know what 5 pi over 12 is. We don't have the exact value for it. So we need to break this apart into things that we know, so some angles we know. So how I kind of thought about this is we have tan, and I'm going to break this up into 2 pi over 12 plus 3 pi over 12 and see, hey, are those on the unit circle? Well, they're not simplified yet. So let's simplify these and see if they actually exist, or ones that we know. So 2 divided by 12, yeah, you get pi over 6. That's on the unit circle. And then we get pi over 4. So that's also on the unit circle. So we can actually do something with this then. If it didn't work, you would have to try different numbers. So possibly you could try 1 pi plus 4 pi and just try some different combinations. There's not actually that many that exist. All right then. So now we have an identity. We have an addition for a tangent, so of two angles. So from the formula sheet, then I'm going to go tan angle A, pi over 6, plus tan angle B, which is pi over 4, all over 1 minus tan angle A. We're going to have to figure out how to change this. So pi over 6, and then tan pi over 4. And that's just from the formula sheet again. Now we can start actually evaluating this. So tan pi over 6 is equal to 1 over square root of 3. And we're adding tan pi over 4, which is just 1. Now on the denominator, we have 1 minus. So tan pi over 6, we already said was 1 over square root of 3, which is kind of ugly to have a complex fraction there. And then tan pi over 4, again, is just 1. Okay, so now we're getting somewhere. Now, how many steps you have to do in here depends on each person. When I'm looking at this denominator, so I'm just going to do some little side work here. Well, I need to have that as a denominator of square root of 3. So really, that's the same as having square root of 3 over square root of 3. So that's going to save me some time right there. Why that's important is I can actually then add this 1 value, plus it's really going to be square root of 3 over square root of 3. So that's going to just save me a little bit of work right now to look at. We're going to leave the denominator. We can do the same thing for this 1 here as well. That 1 is actually square root of 3 over square root of 3. And why that's important is, once again, we do have this denominator square root of 3 here. So this is definitely a tougher question. So I have 1 plus square root of 3 all over square root of 3. Now that's just my numerator. All I've done, I'll do this in a different color, again, is added this 1 plus the square root. For my denominator, I'm going to go, I know that, I'm doing a different color, I know that 1 square root of 3 times 1 is just 1 over square root of 3. I'm not going to worry about that too much. But I do have this in a common denominator, so I get square root of 3 minus 1. So we get square root of 3 minus 1 all over square root of 3. Now you're going to get a complex fraction here. Again, I'm having some problems running out of space. So I'm going to kind of just deal with this in one step. Again, if you're not sure how to deal with complex fractions, leave a comment and we can just send you a quick video to remind yourself. So this is actually going to become, though, 1 plus square root of 3 all over square root of 3 minus 1. Now, unfortunately, we're not done. The square root of 3 has a radical in the denominator, so now I need to multiply by a conjugate. So again, the conjugate is going to take, it's going to be plus 1 instead. So square root of 3 plus 1. What I do to the denominator, I do to the numerator. Now, once again, we actually have a difference of, so we have a perfect square in the numerator, which is kind of nice. And we also have a difference of squares in the denominator. So I'm going to use some of those little tricks to kind of speed this up. So I know it's going to be square root of 3 times square root of 3, which is just 3. 1 times 1 is 1. And then we're going to have that middle term. So because it's a perfect square, it is going to be the square root of 3 doubled. So 2 times square root of 3. Now in the denominator, we have a difference of squares. So square root of 3 times square root of 3 is 3. The middle term is not going to exist. it's going to cancel itself out. So we're not going to worry about it. So negative 1 times positive 1 is minus 1. Finally, our last step, 3 plus 1 is 4. We get plus 2 square root of 3. And then 3 minus 1 is 2. Now we're so close to being done. If you remember from 20-1, you can see that the 4, the 2, and the 2, they all have a common multiple, or common factor, sorry, of 2, so we can divide everything by 2. And my final answer, I'm going to write in the top left corner here. So we end up actually with 4 divided by 2 is 2, plus 2 divided by 2 is 1, so we end up just with 2 plus square root 3. I'll write that again in the smaller writing. So just one more time, it becomes 2 plus square root 3. It's actually not a bad little number. Quite a bit of work though because of the rationalizing. Okay, moving on to our last question. This is a diploma question. I really like this one. It looks very difficult, but it simplifies so nicely. So the expression sine pi over 2 minus theta plus pi over 2 plus theta is equivalent to the expression. So we've got 4 expressions here. They look fairly similar. So this is not a time to guess and check. I would do the work separately and then match my questions. So what I'm looking at, I see I have sine, and then I have a minus, and then I have cosine, and I have an addition. So I have a subtraction identity and a addition identity. So for the sine part, I'll do that in red. So we're going to get sine pi over 2 times cosine theta plus cosine pi over 2 and then sine theta. Now that's just that one identity. That's it. Now for the second one, I'll do it in blue. So we're going to look at cosine. For cosine, we're going to have cos pi over 2. So, and this is an addition between these. So we're going to have cosine pi over 2 times cosine theta. And then now dealing with the second part, you're going to get minus sine pi over 2. No, so close. Times sine theta. Now this, it might look like, well, how can this possibly simplify to one of these 4? Well, the nice thing is when we go to evaluate, so sine pi over 2, well, that's actually just, that's just 1. So this right here, sine pi over 2 just becomes 1. So we actually are just left with cos theta. Now, alternatively, cosine pi over 2, well, that's actually equal to 0. So we don't have to worry about that term then. That term is actually gone. And then, again, we have cos pi over 2. Well, that's equal to 0. So anything times 0 is 0. That one is gone as well. Now over here, sine pi over 2, that's equal to 1. So that's just going to be 1 times sine theta, which is just going to be, now we have to be a little bit careful with our signs here. There was a minus here. Looks like there was a minus there. Double check. Yeah, there was a minus there. So then I'm going to have minus sine theta. And so this question that looks quite difficult has some really nice cancellation. And so you're going to get cos theta minus sine theta, which is C. All right, thank you guys.